Morning, everyone. So today it's Feb 13th, CS 746. Today we are going to discuss about EDA. So here we are at EDA and we completed the hypothesis A/B testing and data visualization. We will discuss later, and data cleaning, data collection, and the rest. Okay, first of all, what is EDA? EDA refers to exploratory data analysis. So whatever we do in the data cleaning is related to EDA. First, understanding the data, removing the outliers, and cleaning the data, missing values, and handling the null values. So everything comes under the EDA. And it's very important to do EDA before you start the model building, so that the purpose that you are building the model will be satisfied only when you clean the data. So if you don't clean the data, your model will not recognize the patterns in the data, and your model will not get a proper accurate. So, and like what are the other important things that are related to EDA? So, as I said, EDA is basically used to identify different patterns, different relations. I think everyone got the data sets right for the project. So, before cleaning the data, as I said, first understand the data, like what are the columns, what you are trying to predict. First understand everything, take some time. And if you have any doubts in understanding the data at any point, you can reach out anyone in three of us. And after that, so these are the some of the important things coming to the EDA. Like you will get maximum insights from the data, and EDA is very important to understand the underlying structure in the data and important variables from the data set. Like for example, if you have a target variable and you are not going to use all the variables that are mentioned in the data set, you are going to finalize only some variables. And what are the variables you are going to finalize is based upon the EDA. And detecting outliers and like underlying assumptions and also the factor settings. It's nothing but you need to clean the data in simple. And okay. So why EDA is important? The main purpose of the EDA is to detect any errors or outliers, and you need to understand different patterns in the data, and it allows analysts to understand the data before making any assumptions. Yeah, like before doing any assumptions, you need to first understand the data. And data scientists use exploratory analysis to ensure the results they produce they are valid and applicable to any desired business outcomes. Because the thing is, when you build a model, like you are not going to use it only for a particular data set, you are going to use it for like other things. So whatever you build that need to be valid for other business problems. It's not only the model that you build will solve the problem related to your data. Once you build the model, that model should be helpful for all the business problems that are related. And EDA also helps stakeholders by confirming they are asking the right questions. So with the help of EDA, like when you clean the data, if you think that you need some more data, then you will ask the stakeholders that I need more data, because in order to solve your issue, I need some more data. And EDA can help answer questions about standard deviations, categorical variables, and confidence intervals. So when you do EDA, you will understand about your data completely. And okay, what are the steps in EDA? Provide descriptions of your sample and features, and you will check for missing data and you identify the shape of your data. So with the help of EDA, you can understand how each column in your data sets is varying, like what are the relationship in that column. And identifying significant correlations, you will identify which variables are highly correlated or less correlated, or they doesn't have any correlation with your target variable. And you deal with outliers in your data set. We discussed about outliers in previous classes. Like for example, the employee salaries. If you compare the employee salaries with the salaries of the board members or CEOs, definitely it will be an outlier because as their salaries are very huge. how to perform EDA. So now let us consider a simple data set. I think everyone know about the iris data set that what we are given in the data cleaning homework. And in iris data set, if you observe, there are 5 columns: petal length, petal width, sepal length, sepal width, and species type. So this is how the iris data set will look. So if you observe, like all our numerical columns expect the species. So species comes under the category. And those are the features and those are the labels. So basically in model building, like in machine learning, I think everyone heard about like supervised learning and unsupervised learning. So when your data is labeled, for example, you have a bag of fruits and some are in orange color and some are in red color. That's all. You don't have any other information. But in the next step, we find some information that what are the fruits that are in orange color? They are oranges. And what are the fruits like in red color? They are apples. So here your data is labeled. So that is the difference between a labeled data and unlabeled data. So in unlabeled data, you don't have the name for your data. Next, provide descriptions of your samples and checking for missing values. Categories. Okay, so now let us discuss about some of the EDA part. You can check the number of rows and columns in your data set by simply like df.shape. So it gives the number of rows and the columns. And like we first load the data set in a data frame. So we first load the data set in a data frame and we check the shape for the data and also the info for the data. When you check the info, you will get all the data types and also the number, like the count of null values. So if you observe that there are no null values in this data. So in order to observe your data, you just need to give this like df.info method. You just need to apply the info method on your data frame. So this is about the shape and the info and describe. So when we discussed about descriptive statistics, I explained that if you applied like describe method on the data frame, it will give all the mean, maximum, and also the standard deviation values. So df.describe will explain what is in the data. So it is not going to help you, like it is not going to predict something, but it is useful to understand what is present in the data. So if you observe, uh, when you see the df.describe for the iris data set, so we can see the mean, the standard deviation, what are the minimum values, and this is 25th percentile. We can consider it as the Q1, and the median is 50 percentile is the median, and 75 is Q3. And by using Q1, Q3, you can calculate the outliers and the maximum value. So df.describe will give you all this information. And checking missing values, duplicates. So this df is null dot sum. So it will check whether there are any null values and next the count of null values. And here the duplicates. So if there are any duplicates in your data set, you need to simply use this code. So in the subset, you will give the column name, like in which column you are planning to check the duplicates. So there are only 3 species: Setosa, versicolor, and virginica. And unique is basically used how many different type of species are available in the data. Is your data set balanced? It's important to check whether your data set is balanced. Everyone will do the data cleaning, like they will check the misvalues, they will check for null values, duplicates, outliers. But it's also important to check whether your data is balanced or not. Because when you train the data, like before the model building, you used to divide the data sets into 2 parts, like 80% for the training and 20% for the testing. So when you train your model, the model should learn all the different classes present in the data. For example, if you observe this iris dataset, it is balanced, like 50-50-50. But what happens if Setosa is, let's consider it is 80, versicolor it is 10, virginica it is like 5. So when you have such kind of data set and you started building the model without managing this issue, so what will happen? The model that you build will get more info from the Setosa because there are like 80, and versicolor is 10 because there are only less. So your model will learn more about the Setosa but not about the versicolor. So you can't use this model for the other, like in order to find out other things, you can't use this model. So whenever you build a model, always make sure your data is balanced so that your model will learn the things correctly. So that you can deal with the bias. So when you build a model, the model should not be biased. Okay. Visualizing the shape of the data. So this is the count plot. We can consider it as a bar graph. So this is used just to observe how many values are there in each species. For example, in Setosa, the count of Setosa is 50, and the count of versicolor is 50, and the count of Ginkgo is 50. So so by using this code, you can get how many, like the count of species in your data. And next, visualizing the relationship. So by using this code, you can see the relationship between two variables. For example, here I considered x equal to sepal length and y equal to sepal width. So the independent variables are denoted by x and the target variables are denoted by y. So whatever you are trying to predict, it will be under y. And the other variables that you are considering in order to predict your target variable, it will be under x. So this is a simple linear regression because I consider only a single independent variable and only one target variable. If you consider multiple, like sepal length, sepal width, petal width, and so on, it comes under multiple linear regression. And next, so this is to get the legend box. I will explain you what's the legend box. So if you see this box, this is what a legend box means. So just getting the box outside of the graph and comparing sepal length and sepal width. So if you observe this plot, uh, the blue one, the orange and the green. So let us see the blue one. So Setosa. So here the Setosa has the less sepal length and the more sepal width. See, the Setosa has small sepal length and it has like higher sepal width. So in that way, we can compare the values between the two variables by using these plots. And next, visualizing relationships. So here, this is simply the previous one, just comparing the two relationship. And next, relationship between the variables. So this is another thing, but here we are comparing the petal length and petal width for all the three species, Setosa, versicolor, and virginica. So this scatter plot, like these data points will explain how the petal length is varying with respect to petal width for Setosa. And this orange color, it will explain how the petal length is varying with respect to petal width for versicolor, and the green for virginica. So in that way, if you want to observe the variables, like the change of variables in your data set, you can consider in this way, like you can draw scatter plots, you can draw histograms, like whichever info you want. If you want the count of different categories in a particular column, you can prefer bar graphs. Strip plot and violin plot. So strip plot is basically useful to get the individual observations. So in the previous slides, like we combined everything, right? Here it is not showing the individual importance, but here if you see this graph, here you can observe the Setosa, you can observe the versicolor, and you can observe the virginica. So you can see this how the values are varying for each species separately in the strip plot. And coming to the violin plot, if you observe the violin plot, violin plot is nothing but the combination of box plot and the kernel density. So this is the box plot. I think everyone can see this, right? So this is the box plot and this is the box plot. and this is the box plot. So, and this, the curve which you are seeing on both the sides, it is the kernel density. It is nothing but the graph of the data that we plot. And multivariant analysis, it is used to compare all the variables. For example, when you are plotting something, you got the data set and there are like 50 to 60 columns and you don't want to include some columns. So you can drop some columns by using df.drop. In the IRIS data set, in the IRIS data set, the ID, it won't give any significance because even though you include ID in your analysis, it is not showing any importance. So that is the reason we are dropping the ID. And axis equal to 1. So this is the column. If you are removing the second column, you can say that axis equal to 2. So in order to drop the columns or variables, we need to use this code like df.drop. And this is the pair plot. Pair plot in simple, it is a grid-like structure and it will explain the relationship between different variables of a species. For example, if you see Setosa, by seeing this plot, we can see how the Setosa sepal length is varying with respect to petal width and petal length and sepal length and like sepal width and sepal length. So just to observe how a particular species variables are varying, you can see the pair plot. Instead of individual plotting, if you want to observe all the variations in a particular species, you can use the pair plot. And histograms are basically used to get the frequency of the species. So this is how the histograms will look. So if you observe, okay, so if you observe the sepal length, highest frequency is 34 and it is between 5.5 and 6 centimeters. So it's 5.5 and 6. The highest is approximately 34. So in that way, you can observe the highest values and the ranges by using the histograms. So if you observe the sepal length, highest frequency is 70 for sepal length. Okay. Yeah. Okay. The highest frequency is approximately 70 and is between 3 to 3 centimeters. Actually, it's sepal width. Okay, so the sepal width is 70 and it is between 3.2 and 3.5. And in that way, you can compare the petal length and petal width. In your data set also, you can compare the frequency values. And hist plot. So this is how the histograms will look. This is just the code to plot that. And here, if you observe one line, like plot.map, hist plot, sepal length, like we mentioned KDE equal to true and stat equal to density. So it's nothing but you are including the kernel density function in your histograms. So this is a histogram, but if you see this, we included some curves. So this is nothing but kernel density function. So if you want to include the kernel density function, you just need to include KDE in your code. And this is how the histogram will look. And this is another thing like for petal length, petal width. So this is how the 3D visualization will look of all the three variables like Setosa, versicolor, and Virginica. And correlations. So we all know about there are three types of correlations, and correlation is denoted by R. And the three correlations are positive, negative, and no correlation. So you decided your target variable and you want to observe like which variables are highly correlated to your target variable. For example, if you are trying to predict the price of the house based upon the square feet of the house. So if you observe the price of the house with the square feet of the house, it is a positive relation. If the square feet of the house is increasing, the price of the house will definitely increase. That is the positive correlation. So one variable is changing with respect to another variable in a positive way. And what is negative correlation? Like for example, consider the age of the house and you are trying to predict the price of the house based upon the age of the house. We all know that if the age of the house is increasing, automatically the price of the house will decreasing. So it comes under the negative correlation. So what is no correlation? There are some variables in your data set which doesn't play any role with your target variable, like ID. In previously, I dropped the ID in the like while plotting, right? So why I dropped the ID? The thing I dropped the ID is because it is not showing any relation with the target variable. So that is a meaning between like positive, negative, and no correlation. And the values of the correlation is -1 to 1. So 1 is the strong positive and -1 is the strong negative, and 0 is no correlation. And like compared to 1 and -1, like some students, they will get confused thinking that -1 means those variables are not correlated. It's wrong. They are related, but the thing is they are negatively related with the target variable. And this is how the correlation, this is the correlation for the iris dataset, and these are the values. So to observe the correlation in a best way, we use the heat map. So if you see this heat map, you can observe which two variables are highly correlated. For example, if you consider petal length and petal width, it is 0.96. And one more important point is every variable is correlated with itself. So if you observe petal width with petal width, it is 1. And petal length and petal length, it is 1. So every variable is correlated itself. And if you see petal length and sepal length, so it is 0.87. And if you see petal width and petal length, it is 0.96. So based upon these values, you will decide which two like variables are correlated. And next, notes on correlation. So there is a Simpson's paradox. So the main phenomenon related to Simpson paradox is, the thing is, when you see the variables, if you observe a pattern in your variables, but when you combine those variables, you can't see that pattern. So this mainly explains the aggregation of the data can be misleading. And next, correlation and causation. In the previous class, I said that the correlation doesn't mean causation. So in correlation, we discuss how one variable is changing with respect to another variable, but it doesn't mean that one is causing the other. So correlation is like it's not causing the causation. So next, detect and handle outliers, box plots. So box plots are mainly useful to detect the outliers. If you see the graph, like if you see these plots and everything, Setosa has smallest features and tighter distribution with some outliers, and versicolor has average features, and versicolor has largest features like Virginica. So this is how the box plot will look like. And if you see these points, so these are the outliers, and these are the outliers for the Virginica, and here versicolor, and here Setosa. So box plots are mainly useful to detect the outliers. And so like in exams, if we ask about outliers, definitely there will be a question on the box plots, and we will give the horizontal box plots. So this is the median for the box plot, and we have the Q1 and Q3 values. And whatever the values that are outside of the quartile range, like in previous classes, I said how to calculate the outliers. Like Q1 minus 1.5 into IQR will be the outliers for on the left side, and like Q3, like I think Q3 plus 1.5 into IQR will be the outlier for the right side values. So those are the formulas to detect the outliers. And so this is the old shape. This is just observing the box plot for the sepal length and sepal width. So I think most of the students understand what is EDA and what are the concepts that we need to consider while doing EDA. So make sure you understand the data set that you got, and make sure it is clean. You deal with the outliers, you deal with the null values and the missing values. So, and also, before going to the data cleaning, make sure you visualize the data, like visualize every column, so that you can understand how the data is varying. And coming to the outliers, don't think that if there is an outlier, I need to remove that. You need to check the importance of the outliers, whether it is affecting your model or not. Then you need to remove the outliers. Okay. And there is one more short lecture. I will stop recording. Just a second.